So 386 is the page I want you on. Page 386. Go back to section 1. Review the types of questions on test. Let's say we look at a question like number 2. How do you know, is this an answer to this? How do we check? How do we check solutions? You plug them in. So instead of x minus 2y equals 5, instead of the x, we plug in a 3 minus 2 times negative 1 and see if that equals 5. Well, negative 2 times negative 1 is a positive 2. Does 3 plus 2 equal 5? Yes, sir. Does that mean it solves the whole system? No, you have to make it work in both. So instead of 2x minus y equals 7, you plug in a 3. Minus, make sure you use parentheses here because this is where you could mess this up. Minus a negative 1 would turn to plus 1. 2 times 3 is 6. 6 plus 1, sure enough, does equal 7. So yes, that is the solution to this system. Remember, the majority of this chapter was not all the shading stuff that we just got done doing. The majority of this chapter was solving these systems. There's 3 methods that you need to know how to solve systems. What were those 3 methods? So substitution, graphing, and elimination. Okay? So that is the majority of this chapter right here. I'll give you a system of equations and say solve by graphing, solve by substitution, solve by elimination. The review assignment started on 4/29. What? 4:30? Is that where it started? Yeah, 4:30. So now, come test day, with those 3 systems, or 3 methods, if the problem says solve by graphing, do you absolutely have to solve it by graphing? No. I would say, though, there is going to be times where you will have to, because I could give you a multiple choice test, because not all the test is going to be multiple choice. I could give you a multiple choice question where I could say, which of these, if I give you this system or a different system, if I give you, what kind of system would you want in order to use solve by graphing? Like, what would you want to see? What would be the only way you would say, ooh, I want to use solving by graphing here? If everything was in slope-intercept form. So you would basically want to see something like y equals x and y equals negative x plus 6. You would want to see something like this. If you saw something like this, yeah, I would probably tend to go, let's use solve by graphing. For the first one, what's my y-intercept? What number's over here? What number's right here? If it's y equals x, and you're comparing it to y equals mx plus b, what's my slope? What's my y-intercept? My slope is 1. My y-intercept is 0. So I would start at 0 and go up 1 over 1. And then I would draw that line. Okay. And then this one, where do I start? Start at 6. 1, 2, 3, 4, 5, 6. And then go, what's my slope? Down 1 over 1, so down 1 over 1. So when you solve by graphing, what are we looking for? What's the only thing we want to see? What's the answer? Where they hit. We're looking for the coordinates of that point, which would be 3, 3. Make sense? Now, should you check your answer? Yeah. Does 3 equal 3? Yep, works in there. Does 3 equal negative 3 plus 6? Yep, works in there, so we know we have the right answer. Absolutely, you need to check your answers. There is no reason to get a question wrong on this test. Seriously, if you just simply solve it by one of the 3 methods, but then go ahead and check your answer, you should always know you have the right answer, right? You should be able to take your test and come back and give it to me and say, don't even bother grading this. I know it's 100%. I've already checked all of my answers. Are we good with these? Solve by graphing? Easy? How would I do this same? Well, I'll pick a different one because that one's almost too easy here. Let's say I wanted to do a problem like, let's do this one. 2x minus 3y equals negative 7, and 3x plus y is equal to negative 5. If you solve this problem, and I just said solve it any way you want, what method might you jump to? Graphing, elimination, or substitution? Which one? Why would you say substitution, Jennifer? This second equation, what's the first thing you have to do with the substitution method? You have to get one of the 2 equations to say either x equals or y equals. Well, this second equation is really easy to get the y by itself, right? What's your question? Uh-huh. These got to be bigger. Okay. So what would y equal? Negative 3x minus 5. Everybody so far so good? So step 1, get one of the variables by itself. What's step 2 in the substitution method? Plug it in. So we rewrite the other equation. So the 2x minus 3y equals negative 7, but we're going to replace the y with what it equals. So instead of this, it's going to be 2x minus 3y, negative 7, and the y becomes negative 3x minus 5. So far, so good? What's the next step? Distribute. So I would get 2x, negative 3 times negative 3 is a positive 9. Negative 3 times negative 5 would be a positive 15, equals negative 7. Combine like terms, 2x plus 9x would be 11x, plus 15 equals negative 7, minus the 15. You get 11x equals, what's that, negative 22? So what's x going to equal? Negative 2? What does that mean about my answer? That the x value of my answer is negative 2, right? How do you find the y that goes with it? Plug it in. You have 3 choices. You can plug it in here, you can plug it in here, or the spot I recommend is the spot you right before you substituted, because it's already solved for y. So I would plug it in right here and say y would equal negative 3 times negative 2 minus 5. Negative 3 times negative 2 is 6. 6 minus 5 is 1. If you're taking the test on Monday, should you just leave this and move on with your life? Why? you should check your answer. The same thing we did with the first problem. If you take this, you should be able to plug it back in and check your own test. You're going to have time to check your own test. Plug it in and say, does 2 times negative 2 minus 3 times 1, does that equal negative 7? Well, that would be negative 4. That would be negative 3. Negative 4 minus 3. Yep, that equals negative 7. Good. Does 3 times negative 2 plus 1, does that equal negative 5? Well, 3 times negative 2 is negative 6. Negative 6 plus 1, yep, that works. It's negative 5. I know I have the right answer now. There's no question of, ooh, I think this is right, I think this is wrong. You should know you have all the right answers. Are we good with these? Okay. What's the next method? What's the last method we got to talk about? Elimination method. So, let's say I gave you something like this. Let's say I gave you this. What's the first step in the elimination method? What's the first thing that has to be true about the elimination method? You have to make sure everything's lined up. You have to make sure the equal signs are lined up, the x's are lined up. Everything has to be lined up. I would say take that first equation, 2x plus 5y equals negative 24. Put the equal sign right underneath the equal sign. Is the 3x already on the correct side? Yep, so just leave it alone. Put it right underneath the other x. Is the 5y on the correct side? No, so I have to move it. That 5y comes over here and becomes negative 5y. And I put it right underneath the other y's. Is the 14 already on the correct side? Yep, so step 1, line them up. Step 2, look to eliminate. What's nice about this problem? Don't the y's already line up and aren't they going to cancel? Should I add or subtract this problem? Add them. Okay. You add, you get 2x plus 3x is 5x. The y's get eliminated. That's exactly what we want. Add those together, you get negative 10. So x is equal to negative 2. Yes? How do you find the y that goes with it? Plug it in. You can plug it in here. You can plug it in here. Wherever you want. So I would probably plug it in right here and say 3 times negative 2 equals 5y plus 14. That's negative 6. Subtract the 14, you get negative 20. And then divide and you get negative 4. But again, I'm not going to be done here. When you get that answer, what should you do next? Check your answers. What's the worst kind of elimination question? What's the one thing that could make this problem a little bit trickier? What if I gave you this? Why is this problem right here a little bit trickier? because they're not going to eliminate right now. I can't just add or subtract, right? So now you have to make a choice. What could I turn a 3 and a 5 both into? 15. So I could turn both of these into a 15 really easily. Or what could I turn a 2 and a 7 both into? 14. Which one should you do? Does it matter? Makes absolutely no difference. Do you want to do the 15s or the 14s? Choice is yours. 15? So this one, I'd want to multiply this equation by 3. So distribute. That becomes 15x. This becomes 6y and negative 3. What am I going to multiply this equation by? Now, if you multiply by 5, you would be correct and it would work. But if you multiply by 5, I'm going to end up with 15x here, right? What would actually be better than 15x? Wouldn't negative 15x actually be just a little bit better? I personally would multiply by a negative, just to try to give myself one positive and one negative. Adding is easier than subtracting. I would do it that way. So I would distribute the negative 5, and I'd get negative 35y and negative 55. Now I can just add those two equations together. Those go away. That would be what? Negative 29y. That's weird. What do I get here? Negative 58. What's 58 divided by 29? Is that 2? There we go. So y is 2. So I have my y value. How do you find the x value? You can plug it in here. You can plug it in here. You can plug it in here or here. The choice becomes yours. Most people, I think, would choose that first one. So you got to do 5x plus 2y equals negative 1. The y is 2. 2 times 2 is 4. Subtract the 4. Divide. And you get negative 1. Should I be done? No. Again, you should check your answers. Your test on Monday, the large majority of it, is just going to be solve this system. Solve it by graphing, solve it by substitution, solve by elimination. The choice becomes yours. Do you guys have questions over those? Okay.